These are Advanced Math Notes, Unit 4, Lesson 2. For 2, graph y equals sine of x. Pretty basic lesson today, something you have learned before, so this is review. Number 1, graph y equals sine of x. We are going to make a t-chart to do this. This is x, this is y, and instead of y I'm going to put sine of x because that is what y is. And over here in this little corner I'm going to draw the quadrantals. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Alright, so that's going to help us get our sine graph out. Again, this is stuff you've seen before. Not quite sure how your teachers last year may have taught it to you. But I'm going to go through. We're going to use 5 key points. We will always use 5 key points, and they are always going to be going around our quadrantals. So 1, 2, 3, 4, 5, and I will start and end at the same place. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so let's just go around and pick up our sine values. Sine values being in the y values. At 0, it's 0. Pi over 2 is 1. At pi, it's 0. 3 pi over 2 is negative 1, and 2 pi, it is 0. 0, 1, 0, negative 1, 0. Okay. Let's go ahead and graph. I'm going to put a 1 and a negative 1. I'm going to mark 2 on there as well. 2, negative 2. The period is 2 pi, so what I typically do is I just come out to the end, put 2 pi, and then I kind of cut things in half. That's pi. Pi cut in half is pi over 2. 1 over 2, 2 over 2, this would be 3 pi over 2, making that 4 pi over 2, which is 2 pi. 1 over 2, 2 over 2, 3 over 2, 4 over 2. All right, 0, 0. Pi over 2 is 1. Pi is 0. 3 pi over 2 is negative 1. And 2 pi is 0. Making this curvy hill and then a valley. And that is our sine graph. Okay, so making this snaky snake shape, curvy snake shape is your sine graph, and that's what our sine graph is going to look. It'll shift right, left, the amplitude will change, the period will change. We will be dealing with that the rest of the week. Okay, on the same graph, we're going to graph number 2, y equals 2 times sine of x. Do you remember from last year what the 2 does to your graph? X to sine x. Well, if you don't remember, we're going to go through. If you do remember, we'll see if it truly does happen the way you thought. Same set of numbers, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we're using the same set of numbers, only now we're multiplying by 2. So it's 0, 0 times 2 is still 0. 1, 1 times 2 is 2. 0, 0 times 2 is still 0. Negative 1 times 2 is negative 2. And 0 times 2 is still 0. So those are new sets of numbers. Again, taking the sine values, the 0, 1, 0, negative 1, 0, or this set of values here, and multiplying them by 2. And I'm going to erase that because I just said we were going to graph it on the same graph. All right, I'll put this one in green. 0, 0. Pi over 2 is 2. Pi is 0. 3 pi over 2 is negative 2, and then back to 0. So we have this higher hill and then lower valley, and there is our y equals 2 sine x function. So if your guess was that it was going to affect the amplitude, you are correct. It stretches it out more. The original one oscillated between 1 and negative 1. 1 was the max, negative 1 was the min. And it oscillated between 1 and negative 1. We only graphed one period, but if we graphed multiple periods, it would continue to oscillate in this fashion forever and ever between 1 and negative 1. This one here is going to oscillate between 2 and negative 2. If we graphed more periods, it would continue to do the same thing over and over, going up to a max of 2 and a minimum of negative 2. All right, number 3, y equals negative sine x. Okay, do you remember what happens with this one? Let's go ahead and make our t-chart. X, and this is negative sine x because that's what y is. Same set of values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, we're just taking all of these values here, or the original set here, and multiplying them by negative 1. 0 times negative 1 is still 0. Negative 1 times negative 1, because there's a negative sign out there, is negative 1. 0 times negative 1 is still 0. Negative 1 times negative 1 is positive 1. And 0 times negative 1 is still 0. All right. So let's go ahead and plot those there. I'll put this one in orange. 0, 0. Pi over 2 is negative 1. Pi is back to 0. 3 pi over 2 is positive 1. And then 2 pi is 0. So what happens is your sine graph ends up reflecting across the x-axis. So instead of a hill and a valley, you have a valley and then a hill. Y equals negative sine of x. Now all this stuff you did learn before about amplitude and reflecting across the x-axis, so that should be review, and this is what we're going to be doing in class. All right, I'm just going to flip to the back page and answer a few questions. Number 1, what is the highest y value for y equals sine of x? What is the highest y value? We just talked about that a second ago. Here's the original y equals sine of x, the one in the blue. And what is the highest point? 1. And it's always going to be 1. Even if I were to graph more periods, it would still be 1. So the answer to that is 1. Number 2. Oh, nope. This is part A. There is a part B. Where does it occur? Where does it occur? Asking or referring to this question, what is the highest y value? It's 1. Where does that highest value occur? They're asking for the y value. What is the highest value? 1. That's the y value, sorry. Where does it occur is asking for the x value. Okay, so I'm going to repeat that. What is the highest y value? Obviously right there they're asking for the y value. Where does it occur is asking for the x value. So you can look at your graph. There's the highest point. It occurs at pi over 2. All right, number 2. What is the lowest y value? For y equals sine of x. All right, so most of you can probably answer that without looking at the graph. What is the lowest value? So we're still on the same y equals sine. There's the highest, it comes down, 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 down. Lowest is -1. Where does it occur? It occurs at 3 pi over 2. Okay, but that's the only question I'm going to ask. What is it? And it is -1. Okay, number 3. Y equals sine of x has a y value of 0 for what radian values? Okay, the function y equals sine x has a y value of 0 for what radian values? So at what x values is the y value 0? That's another way of asking for the x-intercepts. They are asking you for the x-intercepts. For what x value, that's your radian value, for what x value is the y value 0? For, again, the original blue function, 0, 0, 0. There are 3 places, 3 x-intercepts. For all of them, actually, they all have the same x-intercept, 0, pi, and 2 pi. So those are my 3 answers. 0, pi, and 2 pi. Again, all of this is occurring only with one period. We did not graph anything more. Number 4, y equals sine x reaches its max height at what radian value? Now, I've already asked you this question before. It's just another way of asking. Y equals sine x reaches its max height at what radian value? Okay, so here's the y equals sine x. What is its max height? The max height is right here. What is the radian value? Pi over 2. Again, where did I ask you this question at earlier? Here. What is the highest value? That's the same as max. Where does it occur? Where does that maximum occur? Pi over 2. Again, just different ways of asking. So when you get to these questions, you know what's being asked. All right. Next piece is amplitude. Amplitude is half the distance between the max and the minimum value. In parentheses, it must always be positive. Your amplitude is always positive. Why? Because it's a distance, and distance is always positive. All right, I'm going to bubble that in. Amplitude, you do need to know what amplitude is. Okay, half the distance between the max and the minimum value. So looking over here with the blue function, right here, what is the amplitude? The max is 1, the min's -1. That length there is 2. Half of 2 is 1. So here the amplitude is 1. All right, number 2, that's the green one. The highest is 2, the lowest is -2. The length between 2 and -2 is 4, and half of 4 is 2. Amp is 2. And here, it's the orange graph. The max is 1 and the min is -1, and the length between, or the distance between 1 and -1 is 2, and half of 2 is 1. All right, so yes, as you remember from last year, it's not just the coefficient, because the coefficient here is 1, the amp is 1. The coefficient here is 2, and the amp is 2. Now be careful, the coefficient here is -1, but the amplitude is +1. So you want to make sure the amplitude is always the absolute value of your coefficient. We will write that down or show some examples of that in just a little bit. Absolute value of +1 is 1. Absolute value of +2 is 2. Absolute value of -1 is 1. All right, let's try some examples. What is the amplitude? Y equals 7 sine x. Y equals 7 times sine x. Absolute value of the guy in the front. Your amplitude is 7. Number 2. Y equals -3/4 sine of x. Amplitude of the coefficient, absolute value of -3/4 is +3/4. Number 3, y equals a sine of x. One of the most missed problems on the, I shouldn't say most missed, but often missed on the test is this one. No matter how many times I say it in class, remember, 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 I still have a handful of kids that unfortunately forget, so please do not be that kid. Most common wrong answer, kids say, oh, Mrs. Torres said it's the number in the front, so it is A. And you're thinking, well, isn't it A? And it's wrong, because A is A. It doesn't have any restrictions, so A could be -5. And if A was -5, would my amplitude be -5? No. I would need to take the absolute value. So you have to put absolute value when it is, I don't have to put it here because absolute value of 7 is 7. And I kind of did that one in my head. The absolute value of -3/4 is +3/4. Here, the absolute value of A is the absolute value of A, because we don't know what A is. It could be positive, it could be negative, so we have to leave the absolute value in there. The absolute value of A is the absolute value of A. And that is it for this lesson.